and the driving force of redox. Redox stands for reduction and oxidation. So this has to do with assigning oxidation numbers and determining which element lost electrons, which element gained electrons. So oxidation and reduction have to occur together. A species is oxidized when it loses electrons. Now we have to remember that electrons are negatively charged. So when you lose electrons, you actually become more positive. So if you lose the negativity, you become positive. This is hard to keep track of because it seems a little bit backwards when you're losing electrons to become positive. But just think of electrons as a negative charge. So a species is oxidized when it loses electrons. In reverse, a species is reduced when it gains electrons. Reduced is sometimes easier to figure out because when a species is reduced, its charge will also be reduced. It'll go down. So in this case, hydrogen's charge went from a +1 to a 0. It went down. Its charge was reduced, therefore it was reduced by gaining electrons. Zinc, on the other hand, had a charge of 0, and then it went to +2. It did this by losing electrons. It lost the negativity to become more positive. You cannot have one without the other. Reduction of gaining electrons cannot happen without an oxidation to provide the electrons. So somebody can't lose electrons unless somebody's there to take them. Somebody can't take electrons until somebody's there to give them to them. So you can't have two oxidations or two reductions. It's one oxidation and one reduction. Our memorization trick is Leo the lion says grr. Losing electrons is oxidation. Gaining electrons is reduction. We like pictures of lions better, but if you would rather, you can use oil rig. Oxidation is losing, reduction is gaining. So how do we assign these oxidation numbers? This is the same that we've been doing the entire time, meaning that if you have a compound, you have a cation in the front with a positive charge and an anion in the back with a negative charge. So an oxidation number is the same thing as the charge an element will take when it forms an ion. Now, elements standing in their elemental form by themselves, not part of a compound, always have an oxidation number of 0. That means they're neutral atoms. That means they have as many pluses as they have minuses. The oxidation number of a monoatomic ion is the same as its charge. So we went through this. Nonmetals tend to gain electrons. Nonmetals have negative oxidation numbers. Although there are some certain compounds where there's two nonmetals bonded together, then you might have a situation that's a little different. We can usually count on oxygen. Oxygen has an oxidation number of -2, unless it's the peroxide ion, which has an oxidation number of -1. Hydrogen is -1 when it's in the back, when it's a anion behind a metal, but it's usually +1 when it's in front, as in an acid or bonded to a nonmetal. So fluorine is also one we can always talk about. Unless he's standing by himself in its elemental form, fluorine's going to have an oxidation number of -1. Other halogens have an oxidation number of -1 also, unless they're bonded with a more electronegative atom. So those are going to be specific cases that you will not have to concern yourself with this year. We will worry about that next year. So if you have a neutral compound, the sum of the oxidation numbers is always 0. But if you have a polyatomic ion, the sum of the oxidation numbers is the same as the charge on the ion. So now let's see if we can put this into practice. Here's our rules. Oxidation number of any pure element is 0. So let's just show some examples. O2, oxidation number is 0. S8, oxidation number is 0. Mg, oxidation number is 0. Cl2, oxidation number is 0. Number 2, the oxidation number of a monoatomic ion equals the charge on that ion. Well, let's see. Cl minus, the oxidation number is -1. O minus 2, oxidation number is -2. Al plus 3, oxidation number is 3. Pretty self-explanatory there. The more electronegative in a binary compound is assigned the oxidation number equal to the charge it would have if it was an ion. Let's just skip over that one. This is more of an AP concept, but what it means is the element that is in the second position is going to have the charge that it wants. So for example, if I had SO2, oxygen would have a charge of -2. There's 2 of them back here though. So I'm going to have 2 times -2. I have -4 in the back. So the oxidation number of sulfur is going to be +4. That's all that really means. 4, the oxidation number of fluorine in a compound is always -1. So you can count on fluorine to be -1 unless he's standing by himself as F2, then his oxidation number is -1. But if he's an ion, his oxidation number will be -1. Oxygen has an oxidation number of -2 unless it's combined with fluorine. Fluorine is the bossiest one. Or in a peroxide where it's -1. Hydrogen is +1 unless it's combined with a metal, then it's -1. So you've got to look if hydrogen's in the first position, then he's always +1. If he's in the second position, that means that he's going to be bonded with a metal. The metal will be the positive one, and then he can be -1. If he's standing by himself as an H2, then his oxidation number is 0. It's the only 3 things that hydrogen can do ever. In compounds, group 1 is +1, group 2 is +2, and aluminum is +3. Always, every single time. We've gone over that numerous times since the beginning of the year. The sum of all oxidation numbers in atoms is in a neutral compound is 0. So let's just practice a few of those. CO2. Oxygen is -2, but there's 2 of them for 4 minuses in the back. So carbon's oxidation number is +4. Again, oxygen's a -2 every single time. Each of these is a +1. So we're talking about oxidation numbers. We're talking about the individual atom, the charge on each individual atom. So AlCl3, chlorine is a -1, and aluminum is a +3. Same thing we've done over and over again with naming and all the weeks that we've spent on this. This is kind of new. The sum of the oxidation numbers in a polyatomic ion equals the charge on the ion. So for example, nitrate is NO3 with a charge of -1. So this time, all of the oxidation numbers are not going to add up to 0 like they do in a compound. They're going to add up to -1. So I know I have 3 oxygens in back that are -2. It's going to total up to the charge, which is -1. So nitrogen will have to calculate. He's only going to be -3 when he's an anion in back. So he's going to be X minus 6 equals -1. So X in this case, or the charge on nitrogen in this compound is +5. That's because oxygen is more electronegative. Oxygen is better at taking electrons, so he will have the -2 charge that he wants. Let's see. Let's do CO3 -2. So we have a carbon we're not sure what the charge is, but we have 3 oxygens that are -2, and it all has to add up to a -2. So X in this case, or the charge on carbon, is going to be +4. Let's do this is the perchlorate ion. So we have 4 oxygens that are -2, adds up to a -1, which is the charge, and we don't know what chlorine is. So X minus 8 equals -1, and that gives me X is equal to +7. That's the oxidation number of chlorine in this compound. Oxygen's -2. Let's do one where we have more than one. This is the dichromate ion. So I have 2 chromiums. I don't know what the charge is, but there's 7 oxygens that each have a -2 charge, and the overall charge is -2. So 2x minus 14 is equal to -2. 2x is equal to +12. So each x is equal to a +6. And there's the oxidation numbers of my elements in this polyatomic ion. So polyatomic ions are the new ones here. They might require a little bit of practice. Remember, the one that's more electronegative, or the one that's closer to fluorine, usually the one written last, is going to be the one that's more electronegative and therefore will have the negative charge. So carbon in this case, we're not sure what it is, but we do know that nitrogen is -3 when he's in the negative position. The overall charge is -1. So X is equal to +2. The oxidation number of carbon is +2. Nitrogen is -3. This just takes a little practice, so break out your worksheet and give it a shot, and we'll learn some more and practice some more and get another lesson next.